Okay, here is a double slit application. And what we're told, I like this one, it's an elegant problem. We're told that the first order maximum, so it tells us the n equal 1 max, for pure wavelength light falling on a double slit is at an angle of 10 degrees. So right away that tells us where that first order max is. And they want to know if that's true, what is the angle of the second order max? And then what's the angle of the first minimum? So what we expect already, like you should be familiar enough with what's going on here, that you're going to expect the second order max to be close to, not exactly, but close to double that first max. And you're going to expect that that first min is going to occur in between, right? In between the first minimum is going to occur in between the central max and the n equal 1 max, so somewhere between 0 and 10 degrees. Okay, so already you should have some idea of where these are going to occur. So let's tackle part A here first. What is the angle of the second order maximum? So when it comes to these maxes, remember what governs these maxes is d sine theta is equal to m or n lambda here, where we have integer number for n, for m. I guess I'm calling this m. I'm going to go back in here. So n is equal to 0, 1, 2, etc. there for my maxima. So the first order max then is going to be, I can say d sine theta sub 1 for the first one, right, would be equal to lambda, whereas n is equal to 1, right? So that's 1 times lambda. And for that one, I get d is equal to lambda over sine of theta 1. Now, theta 1 is given to us as 10 degrees, so remember that's something that's known. Second order max, d sine theta 2 is equal to 2 lambda, right? So if I solve for d slit separation here, I get 2 lambda over sine theta 2. Now, if you're wondering, like, why is she solving for the slit separation distance? I really like using that because what's cool about that is it doesn't change. So the slit separation distance is like the setup of the experiment, right? Those slits are a distance d apart, and they're asking us about the different fringes that happen with that slit separation. So what's nice about that is I can set those equal to one another, because again, the slit separation doesn't change there. Lambda doesn't change. My thetas are different, and so I have those subscripted. So what I can do is set those equal, and I can say lambda over sine theta 1 equals 2 lambda over sine theta 2. And then I'm able to kind of do a little algebra there and get this relationship. Sine theta 1 over sine theta 2 is equal to 1/2. My lambdas are going to go away there, right? So if I know that sine theta 2 is equal to 2 times sine theta 1, now I can get somewhere, right? Because again, theta 1 is known. So I can do a little algebra, and there I can find that theta 2 is equal to 20.3 degrees. All the steps are in the written solutions if you want the intermediate steps inside there. Cool, so that tells me that's my answer to part A there. So where is the second order max, my theta 2? Now, let's shift gears here. For part B, what is the angle of the first minimum? So remember that for my mins, what's the case? D sine theta equals n plus 1/2 lambda. And again here, n equals 0, 1, 2, integer there. So the first minimum occurs then at m equals 0, right? So here, and they're asking us about the first minimum, so that's why I'm going to be using that. So first minimum, d sine theta is equal to lambda over 2 when the path length difference is equal to lambda over 2. And I can solve that for slit separation lambda over 2 sine theta sub 0 for the m equals 0 case. Okay, so again, I can do the same thing and set the d's equal. The d is equal to the above cases too, right? I don't need to find two min cases to compare to each other because the slit separation, that little lowercase d, that's part of the hardware of the setup, and it'll be the same anywhere. So again, I'm going to set my d's equal here. And so I can use a d from this very first part. So theta 1 is given, so I'm going to use that one. Lambda over sine of theta 1, that's from part A, is equal to now lambda over 2 sine of theta naught. And theta naught is my m equals 0 case for the first min, right? And in here, I can say where theta 1 is given to us as 10 degrees, right? And we want to solve for theta 0. So if I do that, I can do a similar thing that I did before. Sine theta 1 over sine theta 0 then is equal to 2. And that I can do a little bit of algebra there and solve for theta 0 as 4.98 degrees. And this is my answer to part B. And this makes sense. Remember when we started out, we were talking about how we expected that first min to occur between 0 and 10, right? Because we know it's going to alternate between dark and bright fringes. And that's what we found here. All right, part C here asks us, what is the highest order maximum that's possible for this scenario? So this is kind of a cool question here. I'm going to get rid of that. I'll change up color for part C. So I know that the very maximum angle that can even exist is 90 degrees, right? If I'm thinking about my setup, I know that theta max, the very maximum, is 90 degrees, right? You can kind of go back to your tutorial if you're wondering why that is so. I'd say go back to the tutorial, do some review there. So I'm going to use that fact, that maximum. And I'm going to say then, and they want to know what the highest order max is. So I'm going to use the max equation. So d sine theta max is equal to m max times lambda. So we're looking at bright fringes, right? So I'm doing integer multiples of lambda. Solving for d, m max lambda over sine theta max. And remember, if we put in 90 degrees for theta max, that's going to give me m max lambda over 1 here, right? So again, we can go through and set the d's equal, and we'll do that as we've been doing in every part of this problem. So we'll use the original one given in terms of theta 1 because that's known. Lambda over sine theta 1 is equal to m max lambda. And then I can solve for m max. So if I do my algebra here, I'll get that m max is equal to 5.76. And so then you'll be saying 5.76 is not an integer. True. So what that tells us is that we don't get to the m equals or n equals 6 case, that our highest order is m. I switched to m's. I know before we were using n's. It's just the same thing, the integer placeholder there. So the highest order we would get is m or n equals to 5 for this particular case.